Good morning, students. Welcome to the class of chemistry. In our previous class, we had discussed about the covalent bond and ionic bond. In the series, how we can find the number of atoms of a particular element in a compound. In that series, today we will find the empirical formula through which the scientist by analysis find the ratio of number of elements present in a compound from their products. That means in some cases we just know what are the different products formed in a chemical reaction, but we are not aware of the number of elements or compounds in a chemical reaction. So in that case, chemists use empirical formula method to find the molecular formula of a compound to find the number of atoms of a particular element in a compound. Let's start with empirical formula method. To find the empirical formula, what we have given, a compound contains 4.07% of hydrogen, 24.27% of carbon, and 71.65% of chlorine. Its molar mass is 98.96 gram. Then what are its empirical and molecular formula? Now let's take an example to solve this, how we can find the molecular formula of a compound. We have given with three elements, that is carbon, hydrogen and chlorine. Now we have given provided with percentages. That means there we are taking the total mass as 100 grams. So that means according to our percentages, our given mass will be like this. That means 4.07, 24.27 percentages of carbon, 4.07% is of hydrogen, and 71.65% of chlorine. To find the number of moles, we know number of moles is equals to given mass upon molar mass. For finding the molar mass of carbon, given mass is 24.27. Its molar mass is 12.01 gram. Similarly, number of moles for hydrogen is 4.07 upon 1.008 gram of hydrogen, and for chlorine it is 71.65 upon 35.453 gram chlorine. After solving these, we will get the number of moles of carbon. So number of moles of carbon after solving this is 2.021. For hydrogen it will be 4.04, and for chlorine it will be 2.021. So we can write it there, 2.021, 4.04 and 2.021. Now to find the ratio, we will divide the smallest number with each number of moles. So the smallest number is 2.021. After dividing this with carbon, we will get 1. Dividing this by dividing number of moles of hydrogen with the number of moles of chlorine, we will get 2, and 2.021 we will get 1. Now these are the simple ratios, so our ratio will also be the same. So what will we write? 1, 2 and 1. If these are the decimal numbers, then we will write their nearest whole numbers. So according to this calculation, our empirical formula is CH2Cl. That means number of hydrogen atoms will always be the double the number of carbon atoms and the chlorine atoms. Now we need to find the molecular formula. That means we need to find the exact number of carbon atoms, exact number of hydrogen atoms and exact number of chlorine atoms present in a compound. To find the number of atoms, so first we need to find the ratio of molar mass upon empirical formula mass. Molar mass we have given 98.96. Empirical formula mass will be 12.01 plus 2 into 1.008 plus 35.453. So total will be 49.48. So after dividing both these, we will get 2. Now finding molecular formula, we need to multiply this 2 with the empirical formula CH2Cl. So our resultant formula will be C2H4Cl. Clear? So this is the method for finding the exact number of elements in a compound if we just have their percentages or the molar mass. But this empirical formula method is basically the main part of finding the molecular formula in stoichiometric reactions. So in our 3 videos regarding the calculation of number of atoms of a particular element in a compound, we have discussed 3 main methods. One, the ionic bond, and another covalent bond, and today we had discussed about the empirical formula method. The empirical formula method is applicable basically on the stoichiometric calculations. By stoichiometric means if the calculated values and the experimental values of a chemical reaction is the same. That means the ratio of different compounds calculated in a theoretical way or in an experimental reactions will always be same. Then those reactions are or those calculations are the stoichiometric reactions or calculations. So now you must go through these three videos, which will provide you the idea about calculating the number of atoms of an element. Thank you.